After finishing any chapter, we have to do some creative questions, and here is your creative questions from the wave and sounds. This is the first creative question. You can see there is a barrier or a wall, and there is a source of sound, and the frequency of the sound from this source is 1200, that means 1200 hertz, and the temperature of the place is 30 degrees centigrade. The distance between the source and the wall is 18 meter. You have to keep in your mind that the minimum distance for creating an echo is 16.6 meter. The minimum distance, I have written there, minimum distance for echo is 16.6 meter, and the minimum time, the required time is 0.1 second. But there is 18 meter distance. That means you can think that easily the echo can be heard, but the velocity of sound depends on the temperature, as you know, and the temperature of the place is 30 degrees centigrade. So there is possibility not to hear the echo, and there is also the possibility to hear the echo. You have to calculate the mathematics to determine the possibility to hear the echo or the possibility not to hear the echo. So let's go with the problem. This problem is very important for you because this is the first problem, and this is very important problem. The question is, find the wavelength of the sound. You have to find the wavelength. Wavelength means lambda, and of course there is an equation which can help you. The equation is V is equal to F lambda. As you know, here lambda is the wavelength, so lambda is equal to V by F. Here V is the velocity. You have got the temperature already, and the temperature is 30 degrees centigrade. So at 30 degrees centigrade temperature, the velocity will be 30 into 0.6 plus 330. You can use there 332 or 330. I have said before 332 or 330. By doing this calculation, I have got 350 meter per second velocity at 30 degrees centigrade temperature. This is the velocity, and you have to put the value of velocity here, and F is the frequency. The frequency is 1200. This is the given frequency 00, and this is the wavelength of the wave, of the sound wave, 0.29 meter. And the second question is it possible to hear the echo at position S? At position S, that means from this position, is it possible to hear the echo? Is it possible to hear the echo? Let's try to solve the problem. The equation is V is equal to 2D by T, as we know. So T by cross multiplication, we can write T is equal to, by doing cross multiplication, we can write T is equal to 2D by V. By putting the values of D and V, 18 meter is the distance between the source and the wall. The calculation gives us the result 0.1 second. As you know, the minimum requirement of for the time is 0.1 second for hearing the echo, so you can hear the echo easily. So echo can be heard from the position S. Okay, so let's talk about the second problem. This is very important. This is very important, very important problem. There is a person at A and at B. There are two persons actually. One is at position A and one is at position B, and R is the reflector. The temperature of that place is 20 degrees centigrade. And the distance between the A and B is 5 meter, and the distance between the A and R is 20 meter. Determine the produced sound wavelength. By doing the same procedure of from the first one, you can solve this problem, and the answer is 2.87. Please do yourself. The second problem is it possible to hear echo by position by the person at B? Please look at the figure. This is the source of the sound. A is the source of the sound, and there is another person at B, and the question is it possible to hear the echo at the position B? Which is it possible to hear the echo for the person who is standing at position B. That means the problem is very critical. This is not normal problem. Okay, let's discuss about this problem. Okay, the question is it possible to hear echo by the person at B at temperature 40 degrees centigrade for the same sound, 40 degrees centigrade. So first of all, you have to calculate the velocity of the sound at 40 degrees centigrade, and the velocity is 356 meter per second. Okay, now we will talk about the distance. What distance? The sound starts from this point and it covers a path of 23 meter, because the distance of A and R is 23 meter. Then it comes back to B and it also covers a distance of 23 minus 5, RB. This distance means 23 minus 5. So total distance is AR plus RB. Okay, so the total distance is AR plus RB, and AR means 23, as we have found that 23 AR, but RB means AR minus AB. So AR minus AB, AR means 23, AB means 5. So the total distance of the covered by the sound is 23 plus 18 is equal to 41 meter. This is the total distance of the sound. We have to use this equation, V is equal to D by T, not 2D by T, because the sound doesn't cover the AR and RA, it covers AR and RB. So you can't use their 2D, you have to use the D. The total value of D is 41 meter, 41. After putting the value 41 and the velocity, we have got 0.115 second. This is the required time or needed time for the sound. T is equal to 0.115 second. Now here is another problem. As you can see, the person at B will also hear the original sound. As you know, the sound was produced by the A, and B has got the experience of the original sound, and after that he will hear the echo. So you know that better. For hearing the echo, there is a condition that you have to